Hello guys, welcome to my YouTube channel. Okay, so today we will be discussing about cell wall synthesis inhibitors, right? In the antimicrobial section. Now here what you have to know. Guys, what happens when I'm inhibiting the cell wall? There is only cell membrane left for the bacteria, and through this cell membrane water enters into the bacteria, and that causes lysis of the bacteria. That is the bactericidal effect you get, right? Now we have to know how the cell wall is synthesis in case of bacteria. Now what happens here is that, suppose this is the cell membrane, right? And the bacterial cell wall, in the bacterial cell wall, it is made up of peptidoglycan, right? There is one is peptide part, another is glycan part. Now how it is formed? At first there is N-acetyl-menoamic acid, which is converted into N-acetyl glucosamine, right? With the help of phosphoenol pyruvate, I mean this is a substrate, and with there is an enzyme, that is enol pyruvate transferase, right? And after formation of NAG, there's a association of NAM and NAG, right? Now this uh, N-acetyl-menoamic acid and N-acetyl glucosamine together is known as GAG, that is the glycosaminoglycan, right? Glycosaminoglycan. Another part, there is peptide synthesis. What happens here is that one amino acid, that is L-alanine, is converted into D-alanine by enzyme, that is alanine racemase, right? Now this D-alanine is then, what happens, suppose these are the amino acids of D-alanine and they are bonded like a chain. So this is helped by an enzyme, that is alanine ligase, right? And after formation of this alanine chain, there is a bond formation between one glycine chain, right? This is glycine chain, and in between glycine chain and alanine chain there is bond formation, right? And after that, this glycosaminoglycan and this alanine chain, there is another bond formation, and finally what happens, one cell wall unit is formed like this, right? So what I'm saying, this is the cell membrane, right? But this is the cell wall unit, but this unit has to come out of the cell membrane. So for that, there is special lipid transporter is present within the cell membrane, lipid transporter, right? And this is known as bactoprenol. This is known as bactoprenol. Now this one unit of cell wall is come out through this bactoprenol, and finally out of the cell membrane there is cross linking occurring here. How this cross linking is occurring, that suppose this is GAG and this is the alanine chain, this is the glycine chain, right? I should make it in black color. This is another unit of cell wall, and this is the glycine chain. Now there is bond formation. How the bond is formed? The bond is formed between one alanine, right? This is alanine, D-alanine, and one glycine. So here is the bond formation, and this is known as transpeptidation, right? And this transpeptidation is helped by the enzyme transpeptidase. So this is the mechanism how the cell wall is synthesized. So we should control it. How we can control it, right? There are such certain drugs which inhibit this enzyme enol pyruvate transferase, like phosphomycin phosphomycin and phosphidomycin. These two enzymes, alanine racemase and alanine ligase, is inhibited by one drug, that is cycloserine. This lipid transporter, bactoprenol, is inhibited by bacitracin, and we can inhibit this transpeptidation by a class of drug is known as beta-lactams. This beta-lactams include penicillin, monobactams, carbapenems, right? So now what I'm going to do is now we will be discussing individual drugs, right? So suppose these are not active, right? I mean bacteria made resistance against these antibiotics. Now what happens there? If there is resistance against the antibiotics which acts on the cell wall synthesis, so we can use those antibiotics which acts on the cell membrane itself, right? So such antibiotics include like daptomycin and polymycin, right? So they act on the cell membrane, and thus they have their antimicrobial effect. So at first sorry at first we will be discussing about the phosphomycin and phosphomycin. Sorry, phosphomycin and phosphidomycin. So what is its mechanism of action? Its mechanism of action is what? Inhibiting the enol pyruvate transferase, right? And what is its spectrum, guys? Now it has a limited spectrum, right? Because the glucose 6 phosphate transporter is required for the transportation of this into the cell, right? And this particular transporter is present only in case of gram negative bacteria. So it is only effective in gram negative bacteria, right? Because of the need of glucose 6 phosphate chain, and this is only present in case of gram negative bacteria. Now what is its pharmacokinetic aspects, guys? these drugs excreted unchanged in urine, right? So it is used in case of uh, UTI, urinary tract infection. And you have to know that this is a safe drug in pregnancy, so you can use this in case of UTI associated with, I mean, pregnancy, right? There is 7 pregnancy. Now the next drug is cycloserine, right? So I'm telling that cycloserine, its mechanism of action. What is its mechanism of action, guys? uh, it inhibit the peptide formation part, right? Alanine ligase and alanine racemase, it inhibits. What is its spectrum? So you have to know it only active against the gram negative bacteria, right? And if I want to talk about its uses, it is the second line drug that is used in case of tuberculosis. And side effects. Now this is important. Side effects include seizure, psychosis, peripheral neuropathy, right? That is, in single word, it is a neuropsychiatric drug. Right, guys. Uh, if if you really want to know how these side effects are occurring, because a lot of things is not discovered till now. A lot of side effects and why it is occurring because of such drugs, it is not discovered till now. Sometimes and some things, some side effects are discovered, not everyone, right? And the next drug is bacitracin. You know its mechanism of action. I have told you that bacitracin inhibits the bactoprenol, that is the lipid transporter which is present in the cell membrane. And what is its side effects? Now why I'm telling you the side effect, because after uh, telling you the side effects, it will be easier for you to understand the uses of it, right? When I'm telling such thing, should focus here. Okay, so this is a nephrotoxic drug, and it causes bone marrow suppression, right? It is a nephrotoxic drug and it causes bone marrow suppression. Now if I want to talk about uses, it is used in case of skin infection and staphylococcal nasal carrier, guys, carrier. So it is used also here, but remember, for this thing, that is staphylococcal nasal carrier, the drug of choice is different. It is mupirocin, right? So this bacitracin has some effect. So what is this use? This is topical use, right? This is topical use. Now if you think of oral, I mean local use in case of GIT, what happens, guys? It is used in case of pseudomembranous enterocolitis, where the vancomycin is not effective, because normally we use vancomycin for pseudomembranous enterocolitis, right? Now one thing I have not told you here, that we can inhibit the transpeptidation by another thing, by another drug. What is that? Guys, this is the alanine molecule, right? And this is the glycine. So I have some glycopeptides which binds here in the terminal alanine, and that causes there no bond formation between this, right? I have something and like vancomycin, right? So the next drug is vancomycin. Now here you have to know one thing. The glycopeptides are larger molecule, right? And they have poor oral absorption. So it is not well absorbed in case of gram negative bacteria, because in case of gram negative bacteria I have poring channels which are shorter, and this glycopeptide molecule is larger, so its spectrum its spectrum is only it is only active against gram positive bacteria, right? Because of its larger size. Now, what is its use? Guys, we can use it intravenously, also orally. In intravenous, it is drug of choice for MRSA. What is MRSA? Methicillin resistant Staphylococcus aureus. Also for ampicillin resistant Enterococcus faecalis and Enterococcus faecium, right? And if we use it through the oral route, I have already told you that in where I have already told you that in case of here, that is pseudomembranous enterocolitis, we use the drug vancomycin, and if there is resistance against the vancomycin, then we can use this drug, that is bezitracin. Okay, so what are the side effects? Now side effects include red man or redneck syndrome. What is this? Guys, this vancomycin causes release of histamine, and that causes vasodilation, right? So there is redness, so that is why redman or redneck syndrome we seen there. And it is also nephrotoxic, right? So now you have to know some other glycopeptides right? I have already told you about the vancomycin. Now other glycopeptides, till now we have teicoplanin, dalbavancin, telavancin, erythravancin, right? Among these, the dalbavancin is the long acting, longest. And teicoplanin, erythroplanin, these two, they what they do, they basically disrupt the cell membrane, and by this they have their bactericidal effect, right? So other glycopeptides like ticaplanin, dalbavancin, telavancin, they have a common use. What is that? They have a common use, that is skin and soft tissue infection, right? In case of methicillin resistant Staphylococcus aureus. Now, uh, guys, I have told you that pseudomembranous enterocolitis, we first use vancomycin. We can also use uh, bacitracin. Now, remember, the best, if vancomycin is not effective, right, we also can use the fidaxomicin and the rifaximin. The fidaxomicin and rifaximin. If vancomycin is not effective, fidaxomicin and rifaximin. What is its mechanism of action and everything, we will cover in the another video. Thank you. We will come in another video. This is the first part of the cell synthesis inhibitor, or we can say this is very first part, because it has a lot of part which is left here. So I'm coming in the next video. Thank you for watching this video, and if you have any queries, please ask your questions in the comments. Thank you guys. It will be good for you and good for me.